So I got into the habit of learning things for myself and on my own. Like nobody told me to learn those things. At school, I was doing completely unrelated things. And so I got into web development in the beginning, like building applications with HTML, CSS, JavaScript, eventually led to React, eventually led to TypeScript. Just focus your time on going where your curiosity leads you. The more curious you are, the more of a drive you have to become better at any given thing, because you want to do that better, you want to do that more. And so you'll start thinking about, okay, how can I do more of this thing? How do I optimize my time to focus more on this? How do I think about like what do I want to learn? What goals do I want to set for myself? For me, it was at least driven by curiosity and interest in a given topic more than, oh, I want to become really good at this. Like the drive for becoming good at it stemmed from me being curious about that thing.
Hello and welcome to another episode of Devs Do Something. Today's guest is DCBuilder, a pseudonymous dev who works as an engineer at Worldcoin and maintains DCBuilder.eth, a guide to becoming a Web3 engineer. DCBuilder has contributed quite a bit of open source content and research to this space as well. He's written things like deep dive guides on L2s, and he's also created the zero knowledge machine learning community. And in this episode, we got deep into the weeds on ZKML, which is a topic that fascinated me, but I knew nothing about it before talking with DCBuilder here. And we also went into becoming a Web3 dev and leveling up in the industry, and how to decide which communities and ecosystems to invest into in the first place. DCBuilder has developed some heuristics on this that I think are useful for everybody that might be listening to this today. So again, we think this is a great episode for engineers who are looking to get better and level up within the industry. And if you're curious about things like ZKML, there's a lot of really interesting content in here on that as well. So with that being said, we hope you enjoy. As devs, we all love hackathons. They're a great way to boost your skill set, meet other engineers, and add to your portfolio of work. At Superfluid, we've sponsored many hackathons and decided to start putting on a hackathon of our own, the Superfluid Wave Pool. This hackathon is a little bit different though in that it's continuous. It's always open. You can submit any project built on Superfluid at any point throughout the month and have a chance to earn thousands of dollars in prizes depending on how your project stacks up. In just the last couple of months, we've seen dozens of teams build really amazing projects that run the gamut from Superfluid developer tutorials to full-fledged applications to a proof of concept Superfluid StarkNet implementation that we thought was really, really impressive. So we encourage you to check it out today. You can learn more by going to superfluid.finance/wavepool. That's superfluid.finance/wavepool. Happy hacking. All right, we are here today on this fine, freezing cold February day where I am with DCBuilder. Welcome, man.
Hello. Thank you for having me.
Yes, it is great to have you here. We have a whole slate of things we want to discuss today, from things like ZK and ZKML to some of your work at WorldCoin. And then also, I think we're going to talk a lot about dev careers, especially when it comes to getting into this space and kind of charting your path for yourself as an engineer. But before we do all that, we'd love to ask you our standard first question, and that is, how did you get into crypto?
So for me, I've been in the space since around like late 2017, early 2018. I was in high school, like junior, senior year, around that area. And I just happened to be really interested in mathematics at the time. I was watching a bunch of YouTube videos, and I watched this sort of presentation from Jensen Huang, the CEO of NVIDIA, about machine learning. And that sort of got me interested in mathematics, because machine learning, like in order to understand it or to build anything with it, you do need to have like some solid mathematical background. So I was learning like calculus, linear algebra, and that led me to a YouTube channel called 3 Blue and Brown, which is like in mathematics illustrations, explainers, that kind of thing, channel on YouTube. And he posted one day a video about how Bitcoin actually works. So it's like an intro to Bitcoin from the cryptographical perspective or from the mathematical perspective. So an intro to hashing functions, an intro to like some basic cryptography, like public private key encryption schemes, and just how Bitcoin solves the Byzantines' general problem. And I found that really cool. And so for me, like that was my start. I started learning more, just like Googling and watching other YouTube videos, learning about Ethereum, about the EVM, about smart contracts. But I didn't really put that much time into it. It was something that was on the back of my mind. And a few years later, I was watching this YouTuber for a long time called Ivan on Tech. He now is the founder of Moralis, a Web3 development company for they're building like a web development toolkit, or like Web3 development toolkit. And they posted a job posting on YouTube about if you want to be like a crypto researcher or writer. And since in the Czech Republic, where I'm from, the salaries are not that great. I did two internships. One was a front end web development internship where I was doing React, and the other one was a machine learning internship where I was doing some tasks with OpenCV, which is a Python library framework to do computer vision. And so this job was like a lot better. I was able to like sort of explore my curiosity for the space more, while at the same time having sort of a bit of work to do. So that's sort of like my start into crypto. So I started doing like research and writing articles, and that eventually led me to where I am.
Very cool. Very cool. So a couple of follow-up questions on that. You're interesting in that you started from like the pure math interests, and then it sounds like you layered on more and more software engineering and actual practical development competencies on top of that. Like for me, I'm actually kind of the exact opposite, where like when I wanted to figure out how ML stuff worked, I got better results when I just tried to dive in and understand like what gradient descent was and played around with PyTorch and those things. And then kind of backed into the math, where eventually I realized that, okay, I need to go pick up like a linear algebra textbook and figure this out. Have you always been like that? Like starting with math and starting with first principles and going kind of bottom up instead of top down?
Oh, I just went with whatever I found on the internet. I didn't have like a big plan for it. So like the way that I started with ML specifically was that I went on Coursera, because that was like the place where you went to go for courses look for courses at the time. And there was this Andrew Ng course from Stanford, and they use MATLAB. So I started with MATLAB, and they mostly start from like a more rigorous perspective, where they teach you like some beginner calculus and linear algebra before they even dive into using MATLAB. Then I did some MATLAB, but I realized that most development teams in production do not use MATLAB for ML. They use Python or R, and Python is the more preferred one, with TensorFlow and PyTorch and Keras and all the other frameworks. So it was like a back and forth between math and engineering at the same time. But for crypto, is a little bit different for me, where I started from like the researcher side of things, and then I went into development like 2 years into doing research and writing technical articles, just because I didn't see a clear path for building on blockchains. It was 2019, 2020. There was barely any like DeFi applications. Like the only thing that I had used was like Ether Delta or CryptoKitties. There wasn't anything that you'd call a DeFi app or like a Web3 app. So I didn't know that you'd be able to build on it. But the financial use cases were cool to me. So I stayed around, and I was just learning about how it worked.
Makes sense. So you're at Moralis, you're doing research, you're, I'm assuming, writing and maybe making videos. At what point did you flip a switch and decide to get into more pure development in the space?
Mm-hmm. So for me, that was when the research started being less fulfilling. I wanted to dive really into the technicals, but I started to have like a lack of understanding of the things that were happening. Like if somebody releases a new protocol and has like a new consensus mechanism, I had no idea how to measure whether something is good or not good, or like sort of the properties that it inherently has. I can read about it and trying to like create a concept or abstraction of how it works, but there is like this lack of understanding, or fundamental understanding of what's actually going on. And it happened sort of when I got interested in layer twos, and I wrote this article in Mirror, the ultimate guide to layer twos on Ethereum. At this point, I started publishing things on Twitter under my PFP, apart from just like my Morales work, which was pay to read essentially. And I traveled to my first conference, ETH Lisbon 2021 in October. And then I met Miguel Piedrafita on Twitter, and just like a bunch of people from the Aave team, people from just like a wide variety of teams in the Web3 space, Ethereum space. And that sort of opened my eyes to the possibilities of like what you can build, what you can do. And so I started to look more into that. And I also created this PsyOps for myself, where I named myself DC Builder, although I was not a builder. I did have some engineering background or math background, but I wasn't building in the space. So I just like created this sort of persona for myself where it would push me to build, even though I wasn't building anything at the time, because people will always ask me like, oh, you're DC Builder, what are you building? And it's always like this sort of subliminal messaging to myself, where like it eventually led me to where I wanted to be. And yeah, like just started exploring what I could do. I spent like a solid 6 to 7 months, like trying different jobs. Like I had a bunch of part-time jobs in the space, worked for a team called Alongside, which is building crypto market indexes. Worked with a few sort of Solidity educational platforms, or what do you call them? The boot camps, Solidity boot camps. One is Artemis, and the other one is Crystallize. So Artemis is still around; they're still teaching people. So I was like creating educational material. I had already created DevPill. I just wanted to create something for myself to learn, and so I got a bunch of resources, and I felt like, why not? Why just not make it public for everyone? So I created this, and started traveling to conferences, met a lot of people, explored the space, tried learning about MEV, tried learning about Ethereum Core, tried learning about layer twos, like more how they work, different languages for running smart contracts. And after a lot of exploration, I meet a lot of teams and like applying to a bunch of places. Since my friend Miguel joined Worldcoin, like he was talking to me a lot about like the things that they were doing. And I had I met them at an event in person, and we talked a bit. And after like talking about like all the different projects that they were working on, I thought that was a good fit for me to become better as a researcher, like learn cryptography, become a better engineer. I wanted to learn Rust, and like that's the biggest that's the language that they use or we use for most of our projects. So it felt like a great fit because I was able to work on zero knowledge cryptography, which is something that I'm really interested in. I got really interested in at the time, doing Rust, and just like essentially work on all the things that I cared about at the time.
Yeah, I love it. So we'll unpack a lot of that actually throughout other questions I'm going to ask you later. But I like the strategy of psyoping yourself, as you said, right? Calling yourself a builder before you felt like you really were a builder, and using that as an impetus to make things, right? I think that was actually pretty smart. You can, for those of you listening, you can trick yourself into doing what you want yourself to do. So I think you're a really good example of that. But let's talk about DevPill. What is this site? Where can people find it? And like, what was your goal in creating that?
So DevPill, you can find it on the devpill.me website. And it's a public good blockchain development guide where I try to find all of the resources that people were talking on Twitter about, and anything I could get my hands on, and just from talking to people what they used to learn, whether it's Solidity, whether it's front-end development for building Web3 applications, whether it's doing back-end services, whether it's doing infrastructure. So I tried finding everything and putting into one place. And not only that, but also like writing some meta commentary around it to sort of make it less intimidating for people, and just like creating sort of like a guide of sorts where people can go from zero to some introduction of how blockchains work, like the very basics, like what is a wallet, what is an address, how to interact with the chain, like what is a nonce, what is a transaction, what is a smart contract, all these things, just like in sequence, and creating sort of like a pathway that they can go from zero to understanding some basics. And then once they have the basics down, they can try and look for like different specializations, and whether it's front end or back end or smart contracts. Eventually I did a guide on Starknet, how to like learn Cairo, how to build on Starknet. I have some also not technical guides there, some like more socially oriented and soft skill oriented. One is like how to get a job in crypto. The other one is how to acquire social capital in crypto. And so I just try to make something that I would like there to be for myself. And since I got to travel to a lot of conferences like ETH Denver, DEF Connect in Amsterdam, ETH NYC, like a bunch more. So I got to meet a lot of people that I always looked up to, and I asked them these kinds of questions. And they eventually like helped me create the guide, like gave me resources for it. For example, there's an Ethereum Core developer roadmap, which was created by Proto Lambda. He used to work as an Ethereum Core dev for the Geth team, but now he is at Optimism. So like that guide was written by him, and I just wrote a bit of the commentary for it. And yeah, that's sort of what DevBuild is.
Yeah, it's a very good resource for people looking to get into the space and to chart their own path to either getting a job, or even like once they have a job, how to actually acquire some level of mastery, right, and to learn new things. But you have lots of really good advice in there. I mean, do you have any advice that you think people should avoid? Like, do you see any bad advice peddled often to early career software engineers or devs that want to get involved in the space that you think people should either ignore or do the opposite of?
I mean, I think there's very few like disinformation or like intentionally bad advice in this space if you follow the right people. I think maybe like the issue is like when you get started, you don't know what is legitimate, what is not legitimate. You assume that everything is in good faith. And if you start hanging around the wrong crowds in the crypto space, a la like the Shillers, like the financially minded, some VCs, although not all of them, they try to sort of sway you into places for their own benefit, and you sometimes might not have the overview or like the like a broad understanding of the space. So you might get sidetracked and like work on things that are not legitimate. So I feel like exploring at the beginning is sort of something that everybody must do to sort of create a perspective of their own and try and find legitimate people in the space. And work from there. I don't think that like the legitimate people in the space are giving any intentional like bad advice. It's just like sometimes people can fall into like bad local maxima, essentially, where they go into wrong directions in the beginning.
Absolutely. Yeah, I think one challenging thing in the beginning, I think, is to evaluate ecosystems. It's difficult to evaluate ecosystems, especially if you haven't been around for a little while. And you actually, in the Starknet post you have on DevPill, you actually, I think either in that post or a post either right before or after that in the sequence, you talk about how to evaluate a new ecosystem, right? So like how should people evaluate new environments? Like whether it's, hey, I'm a new developer and I'm looking at whether I should build on like Ethereum or Cosmos or this new ecosystem that no one's ever heard of, or if I'm an existing dev and I know what I'm doing, how do I know whether I should learn Cairo or go get really involved in building random tokens on Binance? Like how would you evaluate these different things, and how should people at home be thinking about this?
So for me, the first thing that I look at is the people that are building it. If I sort of think that the people building a given sort of platform or solution or product or anything that I as a developer might care about, it's sometimes good to do like some due diligence on who's building it. That is like a good start. So, for example, in the example of Starknet, you know that it was founded by Starkware, a team of amazing cryptographers from Israel and all around the world. They not only have like leading cryptographers, but leading engineers. The ecosystem is amazing. Their partnerships are amazing. Like if you look at all of the projects that are building on top of them, their legitimacy, TVL might be a somewhat good metric as well, although sometimes it's gameable with incentives. So if you have, for example, good applications and good user experience and TVL that wasn't incentivized, then that's also a good tell sign that it's a legitimate project that's here to stay. Also, sometimes it's just good to start with something and go there, like try that ecosystem for a month or two, and then make up your mind. Don't be too quick to judge something just for its cover. Because that helps you sort of understand like how like the different aspects for yourself, like, and then you can compare with other ones. Like let's say right now in crypto you have like 6 or 7 legitimate environments where you can build applications, right? You have like the EVM where you can build on top of Optimism or Arbitrum or an EZK EVM rollup once they're live, or Ethereum itself. Then you have things like Starknet with Cairo. You have Fuel Labs building their own L2 where you write smart contracts on Sway, which is a fork for like a language built with Rust that's very Rusty like. You have like all of these different platforms, and you don't really know which one is going to win out in the end. And for Ethereum, unlike L2s, it's too early to tell. It's just too early. Like these things are works in progress, all of them, and all of them will gain some market share, and the balance between market share between these solutions will vary. And as a developer, you can just choose one, stick to it, build some applications on top of it, and just hope for the best. Like unless you're starting a company, that decision isn't as important as becoming a better engineer and understanding the sort of tricks of the trade. All of these execution environments at the end of the day have or work on the same principles. Like the knowledge like very strongly correlates across any environment that you're gonna learn. Like if you learn things for the EVM and you like learn how to gas golf every single EVM contract, like write Solidity or like you write Huff or like EVM bytecode or assembly or anything. Like if you learn these things, they're based on computer science principles, like how to optimize some bit encoding and like do some like low level operations to make it less expensive. These sorts of tricks will transfer anywhere. And the same with like building patterns. Like it's very transferable. So I wouldn't sweat it all too much. Just try an environment that you've seen a lot of other people build in. Things that have like a lot of backing, or if you build a project, like if you want to like raise funding, then you'll have to like sort of look into the VCs that are backing that specific ecosystem, if you think they're legitimate or not, and those sorts of things.
Yeah, I think that's really good advice. And I appreciate you starting to talk about like the really important thing here is developing mastery as an engineer, right? And one thing that I find to be completely fascinating about our space is that there are so many people like yourself, like Dagachi, who I interviewed last week, who are really, really young, you know, got into this in high school initially and have just absolutely insane rates of learning, right? Like the amount of things that I've seen young people do in this space is really impressive, especially when put into context with the rest of the tech industry at large. So one question I have for you that I'd like to ask people like yourself that have been able to learn a lot in a relatively short period of time, what have you done to level up consistently as a developer? Like, how have you approached learning new things, getting better, upping your game? Like, how do you think about all of this?
So for me, this came a little bit more naturally because I was doing it already for a few years before I even joined crypto. When I was a kid growing up, I was good at school, but I wasn't like passionate about any given topic. So I mostly just played video games in my free time, and school was easy, so I had more time to play games. But when I was like 15 or so, I was playing games a little bit too much, and I didn't like it, and I wanted to stop. So I started looking like how to sort of stop playing games. It was like that hard for me, so I like actually had to search and like try like how to stop playing. It was a bit of an addiction for me at the time. And this sort of led me down the sort of self-improvement, self-development rabbit hole on YouTube, watching videos. Like having access to the internet and just being able to search like that just led me like, oh, like how do you optimize your like your focus and all those kinds of things. Like how do you learn? There's this great book by Barbara Oakley. I forget the name, but it's along the lines like how learn how to learn. It's a book like that, and it's essentially about a kid that like how to teach kids how to learn math, essentially. And when I was 15, I read that book, and it sort of gave me the initial drive to learn things for myself, and like this initial drive to like be curious. And a bunch of people that I was following on YouTube recommended to just explore and try different things. So I got into the habit of learning things for myself and on my own. Like nobody told me to learn those things. At school, I was doing completely unrelated things. And so I got into web development in the beginning, like building applications with HTML, CSS, JavaScript, eventually led to React, eventually led to TypeScript. Just focus your time on sort of going where your curiosity leads you. And the more curious you are, the more of a drive you have to become better at any given thing, because you want to do that better, you want to do that more. And so you'll start thinking about, okay, how can I do more of this thing? And that's when sort of, how do I optimize my time to focus more on this? How do I think about like, what do I want to learn? What goals do I want to set for myself? It's mostly, for me, it was at least driven by curiosity and interest in a given topic more than, oh, I want to become really good at this. Like the drive for becoming good at it stemmed from me being curious about that thing. And yeah, I think that's a sort of good set of principles to go by. When you're young, explore things, and the things that you're more passionate about, go more into those, and then you'll see it really helps that, because you stop overthinking. You're not worried. You're just doing things that you find fun, and you're eventually gonna find something you're gonna really enjoy doing.
Yeah, I've noticed a very similar mindset amongst this cohort of people that are young, that have learned a lot really quickly. Right? It's just following curiosity as opposed to just trying to like set some lofty goal and hit that. Right? There are maybe some small goal setting things that someone like yourself might do in the interim, but the broader process is really driven by like just an open following of curiosity. So let's talk about the things you're really interested in right now. We had a conversation before we started recording about ZKML and some of your work at WorldCoin, but maybe before we get into ZKML, like what about ZK has you interested these days?
So for me, ZK was sort of a nice combination of all the technologies that I care about. Well, for one, it helps scale Ethereum, which like to me, when I was a researcher, was like the most important thing to solve for Ethereum at the time. So when I was learning about rollups, ZK was always there. Like it was always a mention. Like all these ZK rollups are gonna be so great. They're gonna do so well, and it got me thinking about how it works. I had seen some like posts from Vitalik, but they had like some moon math that I didn't really understand. He had a post on polynomial commitments and a bunch of like ZK terms that I didn't know what they meant. And since I enjoy math myself, I wanted to learn more about it. So that was one. The other one was that there's a lot of really cool people working in the ZK space. And whenever I interacted with people in the cryptography domain or in the ZK space on Twitter, they're really willing to help. They really like, we're good at sort of transferring their passion to other people around them. There's a great podcast called the Zero Knowledge Podcast, hosted by Anna Rose, where I learned like what these people are doing, and so it didn't seem too far fetched, and it was more accessible than other things. For example, like MEV seemed less accessible to me at the time, and yeah, I guess like in between these things, the fact that like it uses cryptography, or is essentially a subfield within cryptography. It has a lot of cool engineers in the space. It has a lot of cool applications. You can use it to make Ethereum better, which like Ethereum is, or was and still is like my favorite network. And it's just a tool that is really fun to use, and like the things you can get, whether it's scalability or proof of computation, computational correctness, and privacy. Like those are primitives that I care about. So it felt really right for me to learn more about.
Yeah, for devs that are, maybe they know Solidity and they've been Web3 devs for a little while. What's like the hello world of ZK? Like, what's like the first thing you should try to build with ZK when you get into that arena?
I guess the easiest thing is starting with CIRCOM. So CIRCOM is a zero-knowledge domain-specific language built by the IDEN3 team. They're doing like a bunch of identity solutions. And this domain-specific language is just like a language that eventually allows you to create zero-knowledge circuits for. So you have this proving system, and you write a piece of code essentially, and this language then gets converted to a zero-knowledge circuit, which you can create a zero-knowledge proof of. And then if you submit that to a verifier, you're able to verify that zero-knowledge proof. And so the hello world is going to the CIRCOM documentation, downloading CIRCOM, and writing a very simple circuit. Maybe you can prove that like number X plus number Y equals 4, but you do not know which numbers X or Y are, but you can create a proof that X and Y together summed up do indeed amount to 4. There's like a bunch of these sorts of examples. 0xSpark, for example, has a great get started guide, where if you go to learn.0xSpark.org, I believe, you have like a set of 7 to 8 video lectures on how to get started with CIRCOM on ZK. So I think like that's the most approachable one that I've seen out there.
Nice. I'll link to the 0xSpark set of tutorials. I didn't know that existed. But 0xSpark, those guys seem pretty cool. And I think they're doing interesting work on the ZK side of things. But what about, okay, this is something else we talked about off camera. What about ZKML? Right. So I've seen you post about this. I've seen you contribute to this community a bit. Can you just introduce us to the world of ZKML and how some of this is actually working? I'll ask some follow-up questions from there, but we'll have a broad intro first.
So ZKML currently does not have many applications. The reason why people got really interested in ZKML is that it's like zero-knowledge proving systems are becoming more mature, and the types of computations that you can create zero-knowledge proofs for, you can like start creating zero-knowledge proofs for ever more computational intensive operations. And as you're able to create like more sophisticated proofs for like more complex circuits, people have started to like think like, okay, like what can we use to really benchmark these systems? And machine learning models are sort of like one of the most computationally intensive things you can do on a computer. And since many people, like right now, machine learning is like the center of every single conversation on tech Twitter, pretty much. So people like started thinking like, oh, can we create zero-knowledge proofs of machine learning models? For me, like how I first heard of it is because when I joined WorldCoin, Remco Blemen, he's our head of crypto, and he was working on sort of this proof of concept demo for creating a zero-knowledge proof using the Plonky 2 proving system for a machine learning network in the context of WorldCoin. So in the context of WorldCoin, there is a use case where if you use zero-knowledge machine learning, you'd be able to get a cool property for the product. I can deep dive into that later if we want, but that's sort of like the reason why I got interested in it, or like why I got pilled. And then I did a bunch of research on it. I looked at different teams that are working on it, and I noticed that nobody really created anything like any publicly facing content, or there was no community around it. So I decided to create the Zero Knowledge Machine Learning community, which is just the Telegram group where I started adding a bunch of people. And now is like the place where people go for discussing ZKML. We have meetings every 2 weeks or so where we just talk about ZKML, different teams, what they're doing, like how they're progressing, different use cases, what it could imply. the state of the art, some papers that have come out in zero knowledge, some benchmarks of some proving systems, how they could be applied or optimized to machine learning models and things of that sort. So yeah, it's essentially, it allows you to take the properties of zero knowledge proofs, whether it's computational correctness or privacy, and apply them in the context of machine learning. So you're able to do statements like, this output came from this machine learning model applied on this input. So in a future, let's say that like Twitter is populated with AI bots, and like a lot of Twitter accounts are just machine learning bots. How do you know that comment was from a specific model, or how do you know that it was from a person or not? So essentially, you're able to do proofs that like, okay, this tweet came from a large language model on this prompt. Provided that you're able to create a proof of this, which is really hard and unfeasible at the moment. But it's sort of like things you're able to do. I can also get more into like some use cases that people are thinking of at the moment.
Yeah, maybe start with the one that would be useful for WorldCoin. We can go deeper into how like WorldCoin actually works maybe in a bit, but yeah, maybe start with that one, and we can unpack it from there.
Yeah. So WorldCoin, I'll talk in the context of one of our products, which is World ID. World ID is this what we call it a privacy preserving proof of personhood protocol. PPPoPP is like a fun acronym. And what it allows you to do is you take a picture of an iris using a custom hardware device that we built that it's called the Orb. And this hardware device has an operating system, has a graphics card, like a CPU, is a fully fledged computer. It has a bunch of sensors. And when it takes this image of your face and then segments the image of the eye and of the iris, it is able to create a unique identifier using a machine learning network, a convolutional neural network. And you delete the original image of the iris. You take this this iris code or this identifier, you put it in a smart contract currently is deployed on Polygon POS. And this smart contract, the property it has is that it's a fork of Semaphore, which is a smart contract built by the applied ZKP team from the Ethereum Foundation. And what it allows you to do is that it allows you to make an attestation, a cryptographic attestation, that I am a unique iris code, essentially, and that I haven't performed an action before. Let's say that you're voting on Snapshot, or you're doing a trade, or you want to claim an airdrop, and you want to prove that you've never done that specific thing before. So you can couple the iris code. You can prove that like your iris code is in a Merkle tree, like a Merkle tree inclusion proof, along with the fact that you haven't done an action before, and do this inside of a zero knowledge circuit. And you're able to prove that you're a unique user without revealing who you are or anything about yourself, and that you've done an action before without even tying like the action to the ID itself. So it's fully private. There's no leakage of information, and you're able to prove to any third party or application that you haven't done an action before, and then you're a real human being, unique, real human being. And so zero knowledge machine learning, the reason why it would be useful is that if we ever make a change to the machine learning model, then the output of the iris code, or like the iris code that would be outputted for the same person would be wildly different. And so you would be able to essentially create multiple identities, which would break the Sybil resistance guarantees of the protocol. And so this would mean for the user that they would have to go to an orb again and get signed up again and create a new identifier. And like every single time we update the model, they would have to go again to an orb. And this is a problem, right? Like it's bad user experience. The person has to keep coming to this device. And this device exists because there's no other way of getting such high resolution, and because it has a lot of like liveness and fraud prevention features. Like Face ID has a hash collision rate of like 1 in 10 million. So for every 10 million, you have a collision, and that's not scalable for billions of people. And if you want to have something inclusive, it's impossible. You cannot use KYC because that's privacy invasive, and because half of the world doesn't have KYC. Like if you go to Asia or like a bunch of different places, like half of the world's population, by an estimate, does not have KYC, so it's not inclusive either. So that's like the reason for the orb in the first place. And zero knowledge machine learning, what would allow you to do is that if you take an image of your iris, you cryptographically sign it by the orb, so you know that the liveness, it has liveness. It was indeed like the iris was indeed on a human being, and you have a cryptographically signed image from the orb, which also has a bunch of like sensors to verify that it's a person, that they are not wearing glasses or lenses, and a bunch of other things. Right? So you have this verified or trusted image. You can encrypt that image and store it in the secure enclave of your phone. So like Android has a secure enclave, or like most Android phones have a secure enclave, and all iPhones pretty much since like the first few iPhones have a secure enclave as well. You encrypt and store this image there, and you download the model locally, and you download the app. Like you already have to have the app, but within the app, along with the machine learning model and a zero knowledge proving library, you'd be able to create a zero knowledge proof of your iris on the new updated machine learning model, and recreate your iris code and permissionlessly insert that iris code to the World ID protocol if there is ever an update for the model. And like you'll be able to permissionlessly keep upgrading your iris without ever having to go back to an orb from wherever you are in the world. And nobody has to give you permission, because the smart contract has a verifier of the zero knowledge proof. Like, okay, this person did indeed run the machine learning model on their iris code, which is encrypted on their device. And we know that this iris code was signed by a valid orb that has all of the right firmware, all of the right security mechanisms, all of the liveness features. So there's no room for Sybil attacks in that. You have like an end-to-end trust assumption that like, okay, this computation will happen correctly. You have some cryptographical assumptions, and you also have some assumptions on the trusted hardware, right? Like the orb hasn't been tampered with. So those are two assumptions you're making, that the cryptography is sound and that the orb hasn't been tampered with, which we have like a bunch of hardware and firmware sort of mechanisms in place to prevent fraud and to prevent like invalid signups or multiple signups for the same person.
That was a really interesting explanation of what you guys could do with it at WorldCoin. But just to make sure that I understand something, and this is probably somewhat inaccurate, but I want you to either confirm or deny this and explain why I might be wrong. But is the idea here with ZKML that you can train models on data without knowing specific things about the data itself, right? Is that the idea? Or am I misunderstanding this? Are there more benefits to this process than just obscuring personal information in the underlying data that I'm training models on? Because if that were the case, I would think that we could just use other more basic cryptography to obscure the actual, like maybe the owner who owns what data, whether this data point is connected to this person. But I'm sure there's something more to it than that I'm misunderstanding it. But how inaccurate is that statement?
This is like the best question you could have asked me, pretty much. There is a misconception that zero knowledge machine learning means zero knowledge machine learning, like as in training within zero knowledge proofs. Like zero knowledge machine learning training for a model, for any significant or like any substantially big model, is already extremely computationally intensive on the most expensive graphics cards on the market today, right? Like if you want to train a model, like all of these companies like OpenAI, Google, DeepMind, all of these, they spend months with like huge server racks to train a model. And this is already hard by itself. If you put that inside of a snark or a stark, like a zero knowledge proof, the blow up would be insane. You'd have to spend like 20 years running on data centers trying to create a zero knowledge proof of the entire training process. Or like training a machine learning network inside of a snark or a stark is computationally infeasible, because training by itself is really hard. And if you do anything inside of a zero knowledge proof, it's like in between like 100 to like 200, 300 times more expensive to do than like doing the computation itself. So it's quite infeasible to train inside of a snark. So this is not sort of the use case that people are talking about when they talk about ZKML. when they talk about ZKML is ZK inference, where you have a trained model that was trained like using standard methods, and you have an input, right? And what you're doing essentially is that you're creating a zero-knowledge proof that the model was applied on some input and it gave you some output. This is the thing you're doing inside of a snark. You have a trained model that's publicly available, and you have some input. And if you put that inside of a snark or a stark, you get some proof that this output came from some model applied on some input. Also, you can use zero-knowledge proofs to hide parts of this computation or parts of this inference. You can hide the input so that you know that whatever this input was, you can prove that it had the right structure, like the right dimensions, but you can hide the actual numbers. So like if there's some sensitive data, you can hide that, or you can hide the model too, although there's less use cases for that. The only use case for hiding the model that I've seen is private Kaggle. So Kaggle is like this platform where you do like machine learning competitions, and people submit the model that like has the highest accuracy. So something you could do is that you have a Kaggle competition where people submit models, but the way that they submit them is that they run a zero-knowledge proof of how accurate they were, and they claim a price based on like how accurate they were. And if it was really accurate, it was the most accurate one, they can claim the price without revealing the model. And once they claim the price, you can reveal the model to whoever entity that like created that competition. So that could be a use case, but I haven't seen like any other use case for hiding the model. For hiding the input is okay. You can hide like whatever you want to evaluate on the model. That seems less far-fetched. But the most important property of zero-knowledge proofs, or validity proofs for that matter, is that you can have sort of this computational correctness or computational verifiability that this output did indeed come from some input fed into some model.
So let me making sure that I fully understand this, and I think this is something that that might help the audience to clarify. It sounds like, the obvious thing here, based on what you just said, training these gigantic models is already computationally intensive enough. There's no way we're going to train them inside of an already of another extremely computationally intensive thing, right? So ZKML is more about like interfacing with these models themselves, either after they've been trained or dealing with the inputs and outputs from that model, and providing additional cryptography protections and obscuring things where necessary when interacting with the models themselves, rather than actually during the training process. Is that a more accurate way of putting it?
Yes. You care about like using a trained model within a snark rather than the training part. You deal with the actual using the model instead of getting the model.
Interesting. Very interesting. So I like the fact that you tied this into the things you're working on at Worldcoin. And I think you also just kind of dispelled some myths about like the way that the Worldcoin team thinks about the scanning of the iris. Like, it's not, as far as I understand, it's not taking a picture of your iris and sharing it with world government or anything ridiculous like that. It's privacy first, right? You guys care a lot about privacy. So what else is a part of your tech stack? Like, what other things are you guys working on a regular basis at Worldcoin?
Yes, so there's a few services, like a bunch of infrastructure that many of my teammates are working on. Like most of them are open source. Like the crypto side of things is open source. We also open source the hardware files for the orb. So if you go to worldcoin.org/blog, there's a blog post on the like open sourcing the orb's hardware. So like we're open sourcing like most of the things as we can, and like as it's feasible for us in terms of like not compromising on security, because people like let's say if you have access to the firmware and there's still like a few security sort of issues there that we're not happy with open sourcing at the moment, then we might postpone that a little bit. But as soon as we're sort of comfortable with the security guarantees, we're going to open source like as many parts of the stack as possible. So just keep an eye on the blog. There you can see like the newest, latest updates. In terms of like how we think about privacy, we already have a bunch of blog posts there as well. So if you want to read more, I strongly encourage you to do so. In terms of things that I'm working on, so for me, I've worked on 2 or 3 things. I've worked on this sort of ZKML experiment when I first joined, and I created the ZKML community. But for me, it became sort of less feasible because the expertise you require to innovate on state of the art is like really, either you're an academic and you're doing like foundational like mathematical, like pushing the mathematical boundaries and optimizing some proving systems for machine learning from the math side of things, or like from the cryptography side of things. So that's out of my reach for the foreseeable like few years. The other thing is that even though like I've done some engineering, like whether it's front end or ML, I'm not a great cryptographer, or I'm not a great like Web3 or blockchain engineer yet. So contribute like making a state of the art, let's say, prover for a machine learning network. Although I tried and like I had a fun time learning about ZK, learning about Rust, I was not able to sort of create a solution that people would use. And so that's sort of like one of my reasons also for creating the zero knowledge machine learning community. I wanted to get the actual experts talking together and see what they come up with. And there's two projects that I'm really excited about. One is Modulus Labs, and the other one is Z-Conduit. So Z-Conduit is building sort of this zero knowledge machine learning library that allows you to take a machine learning framework, export it as an ONNX file, which is like a standard format for exporting models, and creating a zero knowledge proof or zero knowledge circuit out of this standardized format. And this uses Halo 2 or a fork of Halo 2, which is a proving system created by Zcash. And this fork is created by the privacy scaling explorations group from the Ethereum Foundation. And so I've started contributing a little bit in that code base for fun, mostly, and to learn more about like Halo 2 and Rust and ZK. So that I worked on from like, let's say July to let's say end of December or so, just like exploring ZKML, learning Rust, learning ZK, learning more cryptography. But right now there's sort of like a more pressing project for me at Worldcoin, which is the World ID state bridge. So currently World ID is on Polygon POS, mostly because of scale. We have signed up about 1.2 million users. You can see the up-to-date number on worldcoin.org. And this scale involves like paying a lot of gas fees for a lot of like insertions of new identities. We do airdrops. So like once you get the Worldcoin wallet and you get your World ID, you can claim the Worldcoin airdrop. Right now it's an IOU. The token is not live yet, but once we launch, this IOU will be redeemable for actual Worldcoin tokens. And we also airdrop $3 worth of BTC or wrapped Bitcoin on Polygon, $3 worth of ETH, or yeah, I think it's ETH or wrapped ETH on Polygon, and then $3 worth of DAI. And so all of these transactions like happen on Polygon for every single user, and any other network that's on the EVM would be infeasible to subsidize these transactions for. So we subsidize like every single transaction, from the creation of the wallet to the claiming of all these airdrops and to every single World ID attestation that you're doing. And we've like focused on contributing to EIP 4844. So EIP 4844, aka proto-dank sharding, is this Ethereum improvement proposal that's focused on scalability and optimizing the data availability properties of Ethereum so that rollups are able to post more data on Ethereum for a cheaper price with a separate fee market so that they don't compete with other applications on Ethereum. And this would mean a rough like 20 to 30x a reduction in gas costs for rollups, whether it's Optimism, Arbitrum, Starknet, or any other ZK rollup or optimistic rollup out there. And we implemented, or like our team, I did not work on that specific project, but I helped make it happen. We built the KZG ceremony sequencer, or help implement the spec that was built by the EF. And so if you go to ceremony.ethereum.org, you can contribute to this sort of randomness generation ceremony or procedure, where you can move your mouse around, type in a secret, and contribute that specific randomness that you're creating. And this will essentially help a part of this EIP where you're doing a thing called a polynomial commitment scheme. And in order to essentially do this, you need to have a credibly neutral secret that gets thrown away and nobody can recover it. And using the secret, you can set up like this entire system. And in order to make the secret credibly neutral, you have to sort of get the entire community of Ethereum and like have them contribute this randomness so that the secret that gets created in the end to set up this polynomial commitment scheme. I recommend watching or listening to the Zero Knowledge to the Zero Knowledge podcast, the episode with Chen Van Epps from the Ethereum Foundation, and also with Carl Beeks from the Ethereum Foundation. There's an episode on this very like trusted setup ceremony, on the KZG ceremony. So I recommend listening to that one on the Zero Knowledge podcast. This is like a good summary of this. But what I'm trying to get at is that once you have EIP 4844, you're able to scale Ethereum by this factor of like 20 to 30x. So we're considering migrating the main contract, the main World ID contract, from Polygon POS to Ethereum mainnet and doing all of the insertions there and bridging the state of that specific contract to different networks. And so that's sort of like what I was working on. I've done an implementation for Polygon POS for the bridge so that we have backwards compatibility. And the other one that I did was for Optimism. And we're like trying to integrate more as we go. And also I'm exploring like some other things that we could do using like some storage proofs or like some other cryptographic primitives to bridge the state without having to use the native bridges. But yeah, I'm happy to talk more about that if you want.
Yeah, absolutely. So I'll be sure to link to the Zero Knowledge podcast about that because I have wondered for a little while, but haven't had the time to do the research on what this whole ceremony thing has been. It's been on Twitter quite a bit, but this issue of migrating state from Polygon to Ethereum Layer 1 is really interesting. This is probably the first time someone has migrated a ton of data or considered migrating a ton of data from a scaling solution in Polygon or even an L2 to back to L1 Ethereum. So like how are you guys approaching this? Like what would the costs of doing that look like? I mean, if it's 20 to 30x more scalable in terms of how much data you can put on chain, I understand it, but I would assume this is still going to be a somewhat expensive process, no?
So there's a few sort of changes around the protocol itself that allow you to make it feasible. One is batch insertions. So we have this like main service or core service called the signup sequencer. It's a Rust service that what it essentially does is that you have all these orbs all around the world submitting iris codes and like identity commitments to this service. And the service gets all of these sort of insertion requests from all of these orbs. It puts them into batches, and then it calls a smart contract with an insertion request, or just like it submits a transaction on Polygon POS with this batch insertion, and it inserts like all of these in one go. And it also handles reorgs. So like, let's say that you insert, like Polygon POS is known for having like very deep reorgs, like 200 blocks deep, sometimes like around that area. And so if you insert, let's say 30 identities on block, like 2 billion, whatever, and the block 2 billion plus 100, you have a reorg to back to like, and you have like your block with that insertion is uncalled. Then you have to, the signup sequencer needs to resubmit. So the signup sequencer needs to watch the state and then have some sort of guarantee that whatever identity was inserted did not fall through, because otherwise people cannot use their world ID anymore, because the proofs that they create in their wallet will be invalid, because they'll create a proof against a Merkle tree root, which is invalid because it doesn't have that iris code inserted in it. So the Merkle inclusion proof will fail. So this is like the main service that like takes care of all these things. And this like the batching aspect of it means that you're only doing like one call to the contract that you pay for on Ethereum mainnet, like once we're on Ethereum mainnet, once every like whatever amount of insertions. So that makes it cheaper. Second of all, World ID itself wouldn't be on Ethereum mainnet, although you could build it there. Like you can verify proofs on Ethereum, but like you're expecting that the user base is not going to use Ethereum mainnet for the most part. Like you can use World ID there, but it's like most applications will migrate to rollups. That's like sort of the rollup centric roadmap for Ethereum. And so it's a lot better having the state on Ethereum and then bridging the state elsewhere than having the state on, let's say, Optimism, and then bridging the state from Optimism to Arbitrum to ZK Sync to all of these networks. Because for one, your finality is messed up a little bit, because unless you run a full node, you don't really have a guarantee that the state in Optimism will not be like messed up by the fraud prover, or like the fraud prover will not deem that whatever state transition happened is invalid. So you have like this sort of like 7-day problem. So it's better to have Ethereum finality instantly, like as soon as there's a slot and you have like some finality guarantees, like you have 2 slots, two epochs like go by, you have like fairly good guarantee that you have finality, and then take the state from there and bridge it elsewhere. And then once you have it elsewhere, you can create World ID proofs elsewhere. So like any application that wants to have SIB resistance on any network could use World ID anywhere. Essentially, you could be able to make a proof or claim an airdrop as a unique user on ZK Sync or on Starknet or on Polygon, Zero, Maiden, Hermes, like any solution you want, essentially, or Solana, like if there's a bridge to Solana or Avalanche, any network, essentially. And right now, the integration uses native bridges. So like you have the Optimism bridge is a smart contract bridge that talks directly to the sequencer. And if you change the state of the bridge, the sequencer on the L2 geth sequencer needs to pick up that change in the Ethereum L1 bridge. And in order to make the state valid on L2, it needs to include that transaction that you're sending to the bridge. So if I send a root of the World ID tree to the bridge, to the Optimism bridge, the L2 needs to call the contract in which I have World ID like deployed on L2, receive the root, and that transaction needs to be there. And like once you receive the root, you can make World ID attestations on other networks. And this is like a painful process, right? Because you need to use the native bridges, you need to send the message there, you need to make sure that it is there. There is nothing like there's no issue, like you can still create proofs. And if you want to like do this for every single network, it's a pain. And so things that we're looking into is using storage proofs. So if you create a proof that some state existed on Ethereum on some block, and you send that along with the root to some verifier that you implement on any network. So let's say you implement a storage proof verifier on the EVM using Solidity, then any EVM network will be able to verify any Ethereum storage proof. So as long as you deploy that verifier on all the EVM networks, you can immediately have access to World ID state anywhere, essentially. So you just like copy paste the same contract, deploy it on all EVM networks. You have World ID support instantly. And this is a lot better than having to integrate the native smart contract bridge for all of them and like do a bunch of shenanigans about ownability and upgradability, so that if you mess up any deployment and state transfer, like you can change things, or like if you have a protocol upgrade, you can change things. So this is like sort of the things that I've been struggling with for the past 2 months. And something like storage proofs would like make it better. But yeah, like this is sort of like the things that I've been working with, whether it's like the 4844 stuff with the KZG ceremony that I helped a bit with, whether it's doing some ZKML research and writing articles around that and creating the community, and then now with the state bridge for World ID. Those are like the 3 things on my mind for the past few months.
I love it. I love it. Thank you for the breakdown, especially on how you guys are approaching this kind of interesting set of problems with like approaching things with like multiple networks and scalability and storing data. I think that's fascinating. I also think it's interesting when teams get really involved with EIPs or ERCs. And it's interesting to see kind of how the EIP process actually works under the hood. So I'm sure that's been interesting for you as well. Have you learned anything after getting involved with an EIP about how that process works on maybe the human side?
Actually, that's something that like really sold me on Worldcoin. Like being able to contribute to Ethereum as a Worldcoin employee, and like being able to work on virtually all of the things that I care about, whether it's like learning about cryptography, learning about ZK, like learning about like Ethereum Core, like working with Ethereum Core developers. So for me, I learned a lot about the process. I attended like all of the Ethereum Core calls regarding 4844, whether it's the KZG ceremony calls or the EIP 4844 implemented calls. I sort of fell out of touch with the current calls for EIP 4844, but we're not contributing to those anymore because that's more like about client implementations and like some specs and like changing the spec and implementing the spec for all the clients. That's something that like I care about, but I don't have a lot of time to care about it. So it was really amazing, honestly, like seeing all of the devs, like meeting them in person, like from all the client teams, seeing like the dynamics of, okay, like how do you lobby an EIP for all core devs to get included in some hard fork? Like how people sort of think like, okay, this is ready, this is not ready, this spec is like sort of iffy, the implementations are not there yet. You need to audit all the cryptography primitives, right? So like there is a KZG library, and there's a KZG library written in some language, and it's native to some clients, but some clients need to write bindings. And like you need to audit the library, you need to audit the bindings, you need to make sure that all of those implementations are correct. Like this entire process is like back and forth with all of these teams, and like the very complex process of like having all of the client combinations run networks with all of the clients on it, and like not fall out of sync, and like all of these things. Like it really like taught me just the complexity of Ethereum and like the Ethereum development process. I think that was like really cool to learn, and I am glad that I had the opportunity to, and I'm glad to like stay in touch with the Ethereum core lands because it's something that I'll always be interested in. And yeah, I'm really excited to like have taken part of taking part in creating an EIP essentially, or like helping an EIP come to life.
Absolutely, and as you should be. I think it's interesting, especially for people earlier in their career who have done like a ton of development work and they've gotten really into math and they understand things very well technically, like yourself. I think it's always interesting when people with that skill set are thrown into a situation that's far more squishy and social in nature, right? Like, and you talk about this a lot, right? Like how to build social capital as a developer. Like, you know, getting an EIP through is a social process. I mean, there's obviously like you have to audit on the technical side, but there's lobbies. You know, it really is like lobbying.
100%.
Yeah, so I think that's good advice. Do you have any other? Do you have any other like broad advice socially for like devs that want to break out of maybe like their own shell and want to actually get involved in the space and make an impact on the future direction of either Ethereum or different networks? Like, do you have any advice for somebody who feels the need to build some of those more social competencies or almost like lobbying competencies who hasn't necessarily done so before?
Yeah. So on devbuild.me, I have sort of like a social capital section. I recommend reading that. I think it's still, I read it yesterday and like foresight of this podcast to make sure that like it's still up to date. And it's still, I think it's mostly true, and my mind hasn't changed on this. So that's like a good starting point. But like the three main points that I have in order to like acquire social capital or like have more sway over like people in this space is for one, like you follow the people that you really want to be like and interact with them. You build up rapport with them. You eventually are like you build up like a relationship with the people that you want to be like, and that's great because they can help you get better. It can lead to some like work opportunities or collaboration opportunities, or like a few years down the line you create your own project and you can like maybe or hire them, or like it's just really underestimated, like, or underrated, just how much you can accomplish just by talking to people. And people in the crypto space are especially like open-minded and like willing to help everyone, and they're willing to sacrifice their time and like answer some like beginner questions. It's really insane, like just how approachable the biggest experts in the space are. So follow the people that are good in the fields that you care about and interact with them. Another one is just put the things that you're working on out there, like write a thread, like, oh, I'm doing ZKML, I'm doing EIP 4844, I'm doing like whatever, like Solidity optimizations, gas golfing. You'll eventually become known if you post often enough and like you talk to the people in that field, you'll become known in that specific area. So people will have something to know you for. For me, like early on, it was my article in L2s. So I posted this like huge article about like how rollups work, like the differences, like what the teams, who the teams are building it, some tools that you can use to like see different L2s in a different way, like some statistics analysis, whatever, like applications, different ones. So if you have any given interest, like write about it, post a Mirror article or like a Substack or Medium or whatever, talk to people in that area. You'll eventually garner some social capital that way. In-person events are also amazing. If you give a talk or if you talk to people in person, you build up relationships a lot better that way. So if you have the opportunity to go to ETH conferences, whether it's DEF CON, DEF Connect, an ETH local event or ETH Global somewhere, that's really great. And yeah, like those are like sort of the biggest advice, like pieces of advice that I can give. Then there's like different optimization strategies for like Twitter, like how to think about Twitter. But yeah, I feel like that's good enough. And eventually you'll have friends. Once you have friends in any given like space, it's just so much easier because introductions are easier. Your friends introduce you to the people you want to meet in any project that you want. And it's people are approachable. They suddenly are like just one or two DMs away, any person that you care about. And for me, it's kind of fascinating because like a year ago or like a year and a half ago, I didn't know anyone because it was COVID. I didn't chat with anyone. I was barely on Twitter at the time. And so just in a short time span, by interacting with all the people that I cared about and like doing the things that I found fun and interesting and I was curious about, it eventually led me to like having all these wonderful friends. So you get all of these friends across all these projects, and it just makes it like a very welcoming place. And it's really sort of empowering. Like you have friends doing a lot of cool things. You can learn from them. They can learn from you. And it's like a self-reinforcing, like positive spiral where it's just all of your friends become better. Therefore, you become better. You spend time with them. So you have like a sort of natural push to like gravitate towards becoming better yourself. And you get to travel to conferences with them. It's really amazing. I feel like this space is really blessed with having a great social layer and like people that are not entitled or people that are like willing to help anyone and just like form relationships with you, no matter your background, no matter your expertise at the given point in time. It's really amazing. So I feel like that is something that everybody should try to get for themselves, and it helps everyone, including yourself.
I think you're right. Smart friends definitely make everything easier. And this is definitely a place where you can find smart, open-minded friends. So I think that's very good advice. And I'll make sure I link to that section of DevPill as well. But listen, no, we're coming up on time. I appreciate you dropping so much knowledge on things like ZKML and how to actually grow your career in this space. But a couple of final questions as we wrap up. The first one is outside of the things you're learning right now, if you had unlimited time, what else would you like to explore or focus on in the space? Any other languages, any other ecosystems, any other topics that you're interested in exploring one day?
So if I had unlimited time, I would probably do a lot more math that I'm doing now. I'm doing like just the necessary math that I have to learn to do the things that I want to do one day. But it's always like a balance between like all things that are pressing for work at the moment because we have some timelines for some like release and some like integration, some things. So there's like always like this balance between like things that are pure curiosity, things that are useful. So like I'll do a lot more of the just pure curiosity type things, I think. In terms of languages, I think I'm gonna try a little bit of every single like ZK DSL or like L2 language. So I'm gonna try like Sway. I'm gonna try Cairo. I've tried it a little bit, but I haven't done like any production project. I want to do more like cryptography protocol implementations. So like take a paper and implement it. That's something that I want to do this year. I guess like outside of the space, there's a few things that I'd like to try, like outside of crypto altogether. I'd like to like maybe learn more AI ML, do some things with that. I would like to maybe learn a little bit more about physics because that's something that I've always really liked, but I had to put aside because I felt that like physics is less useful in a way, where the sort of route to having an application within the physics domain is really far removed from your day-to-day work as a physicist in most fields, unless you're applied. So I felt like computer science and engineering is a lot more useful and like something that I can have more of an immediate impact in, and have like still like do the same things that I enjoy. And yeah, I guess like those are the things that I would be learning.
I love it. Yeah, no, I always like asking that question because I know everybody tends to have a backlist of things they'd like to focus on. But I'm with you there on physics. Physics is very interesting, but it's tough to almost justify all the time you'd spend on it because it's hard. But it's so much easier to produce something directly useful in computer science or with with just engineering in and of itself. So I feel you there. Okay, so last question. This is far more general, but this is about just how you see the industry unfolding. Let's say we zoom out a bit and we think like 10 years in the future. Let's say it's early 2033. We've fast forwarded. What do you hope crypto has accomplished at large? Like, what do you hope the industry looks like? What do you hope the impact of the space is on the world?
So essentially, permissionless applications that are accessible to everybody in the world, anywhere. Just like applications where people own their own data, they own like their own identity, they have access to all the financial primitives, all of the games, all of the things that there's like a very interconnected world where everybody has sort of right to access everything. And there's no disparities, or like there's no difference of opportunity. Like everybody has equal opportunity. I feel like AI will greatly like balance the sort of power the power plays in the world, where it will create so much value, and sort of like part of, for example, like Worldcoin's vision is like once AI generates like insane amounts of value because it's headed that way, or like that's sort of like what we're extrapolating into the future from like what we've seen this field do up until now. So like provided that the technological growth goes the same way it's been going and like goes on the same curve, I feel like there will be virtually limitless value close to that time, not necessarily 2033, it could be 2050, 2045, 2060, even if it's like a little bit later. But I feel like that's something that will have to be figured out, like distributing value generated by AI. And I think like Worldcoin is like the identity layer where you could use like Sybil resistance to distribute that value on top of. And just have the right to privacy, have the right to identity, to ownership for everyone, anywhere, anytime. That's something that I wish that crypto would accomplish. Well, of course, like whilst preserving like social structures and stuff. Like not, I'm not a sort of I don't like anarchism. I'm very far from that. So like up to a degree, but I'd like people to have equal opportunity anywhere and not be like phased by local sort of market dynamics, which might like, severely worsen somebody's quality of life.
Very good answer. Very good answer. Well thought out as well. I agree on several of your points there. I hope similar things unfold. But listen, DC Builder, thank you so much for coming on today. Before we jump, I'll make sure people are linked to your Twitter and DevPill in the show notes. But is there anywhere else you'd like people to follow you online?
I think Twitter is like the biggest place, like twitter.com/DCBuild3R. My Telegram is the same handle if you want to send me a DM. And I think like those are the two biggest places where I'm at. I think that those are good. Or in person, like if you're at a conference, just hit me up. Maybe I'm there.
I love it. Yeah. So go follow DC Builder on Twitter, guys. And yeah, thank you again for coming on, man. This has been a fun conversation.
Thank you for having me. It was a pleasure.